I'm StellarSatya. We've covered the theory, now it's time to build. Today, we install ROS2 Jazzy across Ubuntu, Windows, Mac, and Docker to create your robotics foundation. Let's get to work. ROS2 Jazzy Jalisco is built for Ubuntu 24.04 LTS Noble Numbat. For a production robot, a native installation is always the gold standard. It removes the virtualization layer, giving your nodes direct access to hardware and timing. First, we prep the environment. Open your terminal. We start by ensuring our locales support UTF-8 and adding the ROS2 apt repository to our system. Once the repo is added, we install the essential development tools sudo apid update and sudo apt install ROS DevTools. Now, the main event. For a full workstation, we install the desktop version sudo apt install ROS Jazzy Desktop. If you're building a headless robot with limited storage, use ROS Jazzy ROS base instead. It skips the GUI tools like RVs and Gazebo, keeping your footprint light. Not everyone starts on native Linux. On Windows 10 or 11, the most efficient path is WSL2, the Windows subsystem for Linux. It provides a high-performance Linux kernel inside Windows. You'll follow the same Ubuntu 24.04 steps within your WSL terminal. For Mac users, especially those on Apple Silicon M1, M2, or M3 chips, UTM is your best friend. It's a versatile virtualization tool that allows you to run the ARM64 version of Ubuntu 24.04 with near native speed. If you need absolute performance on Mac, building from source is an option. But for most, a virtual machine provides the stability needed for development. In modern robotics, we don't just install software, we containerize it. Docker allows you to run ROS2 Jazzy on almost any host OS without worrying about dependency hell. To pull the official Jazzy image, Docker pull osrf ROS Jazzy Desktop full. And to run your first container, Docker run it name master osrf ROS Jazzy Desktop full bash. For complex robots with multiple sensors and nodes, we use Docker Compose. It allows us to define our entire robotic stack, talkers, listeners, and navigation in a single YAML file. One command, Docker Compose up, and your entire system breathes to life. Finally, we move to the hardware. Single board computers like the Raspberry Pi 5 or NVIDIA Jetson Orin are the brains of your robot. On the Raspberry Pi, we flash Ubuntu 24.04 LTS 64-bit. Since it's a Tier 1 supported OS, the installation is identical to your desktop. For NVIDIA Jetson users, we leverage Jetson containers. This allows us to build ROS2 images that are pre-optimized with NVIDIA's CUDA drivers, ensuring your computer vision nodes run with hardware acceleration. Installation is only half the battle. We must verify source your environment source chopped ROS jazzy setup.bash. To make this permanent, add it to your bash rc. Echo source opt ROS jazzy setup or bash into your tilde.bash rc file. Run the Talker demo in one terminal, ROS2 run demo nodes.cppp talker. Then in a second terminal, run the listener, ROS2 run demo nodes.py listener. If you see Hello World streaming across your terminal, congratulations, your foundation is set. I'm StellarSatya and the real build starts now.